Struggling with pagination in your Node.js REST API? Offset pagination can simplify fetching data for your users while keeping your backend efficient and scalable. In this video, I will break it down step by step, showing you how to implement it seamlessly. Hi, my name is Alex. I'm a senior software engineer with years of experience in JavaScript and Node.js. My goal is to help you become a confident and stress-free developer by increasing your skills and proficiency. Let's get started. When presenting information to a user, such as a list of tasks, orders, or products, you don't want to show thousands of them at a time, because on one hand, it is not a good user experience, and on the other hand, it may be inefficient to retrieve all the records from the database in one go due to memory constraints. A better way is to break down data into small manageable chunks or pages. Offset pagination is a commonly used approach. Let's take a look at how it works. From the client perspective, the client needs to request a page that it wants to show to a user and a number of records per page. On the server side, an API needs to convert page and per page to limit and offset for the database to understand. Page becomes a limit or a number of records to retrieve, and per page multiplied by page minus 1 becomes an offset, a number of records for the database to skip before retrieving the requested records. After the records are retrieved, the API sends them back to the client. However, for the client to correctly display pagination, it needs one more piece of information: the total number of records. The total number of records is needed to calculate the number of pages. Since the client already knows how many records per page it is requesting, it can divide the total number of records by records per page and round it up to the next whole number. Since the server also knows the total number of records, sometimes it is better to provide pagination information back to the client in the response, so the client can just simply pass it to the pagination component. We will do just that. Since now it is clear how the offset pagination works, let's go ahead and implement it. I am in a Node.js Express project. What we're building here is a Task Manager API, and as usual, the link to the code for this video is in the description below. Earlier, we implemented a repository pattern to abstract data retrieval. If you want to learn how to do it, check out repository pattern video. Let's go to src data repositories folder. In the repository.ts file, we defined interfaces. Let's go ahead and add two more interfaces. We will export iTask query result interface that will have the task property, an array of iTask objects, and total count property, a number. In the similar way, we will define iProject query result interface with a project's property of an array of iProject objects and total count property, a number. We also need to modify the list tasks and list projects method in the iTask and iProject repositories to return the iTask query result and iProject query result respectively. Now let's update the actual task and project repositories to comply with the changes. But before we do that, if you are learning something new from this video, please like and subscribe to our channel for more videos like this. In add task repository.ts file, we will import iTask query result from repository. We will update list tasks method to return type to be iTask query result instead of an array of iTask. In list tasks method, we will define a variable where and assign it to an object with a user ID and project ID properties. Instead of task find many method called on Prisma client, we will use a Prisma transaction. This transaction will wrap task find many and task count methods called on Prisma client. To be consistent in querying and returning tasks find many and count, we'll use the same where object that we defined earlier. Take and skip properties on find many will be assigned limit and offset coming from the query object respectively. Finally, instead of simply returning tasks in list tasks method, we will return an object containing mapped tasks and total count, complying with the iTask query result interface. In add project repository.ts file, we will make similar updates. We will import iProject query result interface from repository. We will update list projects methods return type to be iProject query result instead of an array of iProject. In list projects method, we will define a constant where that is an object with a user ID property. Instead of project find many, we will use Prisma transaction to call find many and count methods on project passing where object and using take and skip to account for limit and offset. We will return an object with a projects and total count properties complying to iProject query result interface. Now we need to update tasks and projects controllers to get limit and offset from pagination parameters and also return tasks or projects to the client with a pagination metadata. Since we will need to get limit and offset from query parameters for both tasks and projects, let's create a utility function getPagination parameters to avoid code duplication. In utils.ts file, we export getPagination parameters function. It will accept rec and express request as a parameter. No pun intended. In the function, we will parse the page and per page query parameters from the request. We will validate the parsed values to ensure they are valid numbers and greater than 0. If the per page is not specified or less than 1, we will assign a default page size value from the config object. We will calculate the limit, number of items per page, and offset, number of records to skip, based on the validated page and per page values. And we will return the computed pagination parameters, page, per page, limit, and offset. Finally, at the top of the utils file, we will import request from express and config from config. And speaking of config, let's go ahead and define default page size property on the config object in config.ts file. Now we are ready to update the code in the controllers. In the tasks controller, we will import getPagination parameters from utils. In the listTasks method, we will destruct page per page limit and offset from getPagination parameters function, calling it with express request as an argument. We will call repository listTasks method with calculated limit and offset. Finally, we will send a response containing tasks, page, per page, total pages, and total count properties. In the projects controller, we will also import getPagination parameters from utils. In list projects function, we will destruct page, per page, limit, and offset from getPagination parameters function. We will call repository list projects method, and after we get the result, we will respond back to the client with a JSON containing projects, page, per page, total pages, and total count of the projects. In the list project tasks method, we will follow a similar approach. However, in addition to using the calculated limit and offset from getPagination parameters, we will include the project ID from the request to retrieve tasks associated with a specified project. The response will be the same JSON object structure as in the list projects function. We are all set. Let's check if the code works. Let's start the dev server with npm run dev and go to API test.htp file. Let's update get tasks request with the query parameters per page equals 4 and page equals 2. After making a request, we receive a response containing not only tasks, but also pagination metadata specifying the requested page, number of records per page, total pages, and total count. Let's also make a call to get projects. This time we won't add any query parameters. Although current user only has one project, the response will contain pagination metadata with page defaulting to 1 and per page defaulting to 5, the number of default per page results specified in the config. As you can see, it is fairly easy to implement offset-based pagination in the context of an API. Compared to cursor-based pagination, offset pagination has several advantages. For instance, you can jump to any page immediately, you can skip 200 records and take 10, which simulates jumping straight to page 21 of the result set. This is not possible with a cursor-based pagination. You can paginate the same result set in any sort order. For example, you can jump to page 21 of a list of user records sorted by first name. This is not possible with a cursor-based pagination, which requires sorting by a unique sequential column. However, cursor-based pagination has an advantage over offset pagination when number of records is large. For example, if you skip 200,000 records and take the first 10, the database still has to traverse the first 200,000 records before returning the 10 that you asked for. This negatively affects performance. So, if you would like to learn how to implement cursor-based pagination, please watch this video next.